Alright, here's my latest hypothesis, of how to go ahead and apply Clarence's successful replication of Barbosa and Leal in a manner which is slightly different, and I will describe all of the particulars. Let's see, the first thing I think is what's happening in Barbosa and Leal is that we have a rotating electric field. Eric Dollard and Peter Lindemann talked about this when Peter interviewed Eric. I think it was over a year ago, or slightly over a year ago. So that would mean it would have been the fall of 2014, was it? Yeah. Let's see, 16? No, that would have been 15. So I'm wrong. It would have been over 2 years ago. It would have been the fall of 2014, because I was still in Washington at the time. So, in the fall of 2014, I believe, Peter Lindemann interviewed, and they were having a open to phone questions. And somebody posed a question, and Eric, I think they brought it up, that electricity does not run down a wire from the power company to, along the transmission wire in a straight path. It takes a spiral path, and that means that the electric field is rotating, and I think they were implying that the electric generators at the power plant are what's creating that rotating electric field. But in a flashlight, for instance, when you just have an LED or whatever flashlight bulb and a battery, a DC battery, I'm suspecting there is no rotating electric field. And Tesla was big on this, rotating electromagnetic fields. And that's how he came up with the AC generation. He had this vision of rotating magnetic fields, which implies that the electric field also rotates, though. That's a thing it's easy to overlook. So I suspected that Barbosa and Leal, that's one of the requirements, one of the factors in the system, because there's so much detail and attention that Clarence has paid to the correct windings of the toroids and of the electric keeper and the Captor loop, and then how to connect the two toroids if you're using a two-toroid system. So it becomes obvious that, to me anyway, that it's very important that we conceptualize, imagine that the electricity is traveling in a spiral pathway along the circuitry. And for that purpose, if I wanted to mobilize Barbosa and Leal and make it adaptable to a car, then of course I have to give up grounding rods, and I have to understand what to do with that. But I also have to be able to give up the AC inverter, the sine wave inverter, because my car and most electric cars, the cheaper ones, the ones that are economical to build for people, are DC electric powered. They don't use AC motors, they use DC motors. And I thought, okay, for simplicity's sake, I should go to DC. But I should have a rotating electric field and a rotating magnetic field traveling inside the wires of the circuitry. So what I imagined was to take out the AC inverter and put in two sources of energy connected in parallel with each other. So let's see if we can focus in here. And that would be a DC motor and a battery. And the battery's sole purpose, if the whole circuit works correctly, in building up energy inside the electric keeper to become a self-runner. That means the battery won't be needed anymore, and the DC motor will simply be there to keep creating an influence, an influence independent of the remainder of the circuitry, to maintain a rotating electric field and magnetic field within the circuitry. So that means that if this system is not set up adequately efficient enough to be over unity, and thus a self-runner just idling, we're just talking about idling at the moment, then the DC motor is insufficient, and so I should have a little solenoid down here switch, a solenoid switch. So I got a coil here powered by the circuit running to the DC motor, the leg, the branch, and a little spring over on the left side to throw this switch over to reconnect the battery. So until it runs, and it may be a question of bringing up the RPM on the DC motor, so that maybe this has to flash on and off periodically as the RPM of the DC motor increases. So I should probably have a flywheel in here to maintain momentum that is garnered by the DC motor. So I'm going to have to add, why don't I stop the movie here and add in a flywheel. Okay, sorry for the shaky camera. I think I'll have to ask YouTube to steady my my video. So here I stuck a flywheel on the end here to maintain momentum of the DC motor as this switch keeps shutting on and off, so that hopefully the flywheel will build up speed. Hopefully. So let's see, let's back up again. So I wanted to make this mobile, and I wanted it to be DC, which means I had to understand where is the magnetism coming from. It's not necessarily coming from the Earth alone. Actually, there are two influences the magnetic field of the Earth is doing. One is, it is magnetizing the steel grounding rods, but two, it's also blowing out the semi-dielectric between them, the soil. So I was wrong in my little essay. I'm going to have to rewrite that. It does both. And that's because the soil is not steel. It probably would not help if it had an iron content, now that I think of it. Our soil around here, it has a lot of iron oxide. Because that might serve as a magnetic coupling, a loose magnetic coupling between the two sets of grounding rods, which undermines the ability for the soil to act as a dimagnetic, shall we say, something that splits the two magnetic fields, not just be a dielectric. So it has to be both. It has to be a dimagnetic and a dielectric, in that it creates duplicity between the two sets of grounding rods, both their magnetic field potential and their electric field potential, or else it doesn't work. So what I learned, I say this because I learned this when I was developing my earthing bedsheet enhancement tool, my earthing, if you know anything about earthing, over at earthinginstitute.com or earthing.com, the appliances you can buy, or the book Earthing by Marty Zucker and Clint Ober and Dr. Stephen Sinatra. There's a very simple procedure of sleeping on an earthing sheet connected by a grounding wire that goes out connected to a grounding rod. Just a simple 1-foot grounding rod. Nothing, 8 foot, nothing like what Clarence was talking about. And I figured out an enhancement based on the study I was trying to do to figure out the electromechanical water ammeter as an example of Tesla's special generator, which is a very poor example, and William Line admits that. It's a watered-down version. I focused on the iron of the trimetal definition of today's nomenclature version of Tesla's special generator. We call it a trimetal generator. He called it his special generator. One of the metals is iron, and Tesla says, according to William Line, for every 200 pounds of iron added to the system, connected to the system, 1 horsepower is added to the output, in addition to whatever the output would have been otherwise, without figuring in the mass of the iron. So we keep wondering, where's the iron? And I think it's in the toroids, is where to find it. And that's where to connect the Captor ground, the 56 grounding rods, connected to the Captor loop. It should go connected directly to the iron mass of the toroids, which means they should be bigger, and skip the Earth as a source of geomagnetism. But we need a reference, and we need the reference separated by preferably soil. And when I did my experiment at earthinglife.info, I found that if I create an aluminum foil shell around my two toroids, without any added separation between them, just the separation of the insulation on the windings. The Kundalini influence of waking up the Kundalini while sleeping at night was tremendous. I couldn't sleep, and the whole point was to enhance sleep, to enhance the restfulness, the depth of sleep, so that the healing of sleep can occur, and that can't happen if you can't sleep. So I realized I had to separate the aluminum foil shell surrounding my wound toroids, because the toroid was simply serving as a piece of iron around which the grounding wire is wrapped around, the wire though, and the grounding wire is an open circuit leading from the earthing bedsheet to the grounding rod outside. It's not a closed circuit. But it's wrapped around iron, and that helped. That actually helped. And the massive iron also helped. And it also helped if it was a toroidal massive iron that I wrap the wire around. Now, I did make one error back then, and I never corrected it. And looking at Clarence's circuit, I am reminded of that error. I had two toroids because at first I was lazy and I connected to the grounding port on our electric outlets to use for my grounding, instead of using a separate wire going to a separate grounding rod outside, spaced away from the mains by more than 10 feet. The more the better, from anybody's mains, such as neighbors. And I also went to a conifer, a very, like 100-foot tall conifer tree that I nailed my grounding wire into, which is also a slight enhancement of a sort. But when I was using the grounding port on the electric outlet, there was an AC bleed over, which anybody who has an electric car, an electric guitar or electric amplifier for electric guitars knows. There's a bleed over from the hot wire to the grounding wire of the AC hum, and you get that. So what they put in, like electric bass guitars, they put two coils that are counter-wound. One is clockwise, the other counterclockwise. They're connected together in series, and then you have a balancing switch between them, because there's going to be a slight difference between them, even though they're wound the same. And that neutralizes, for the most part, the AC hum, which is a little distracting when you're trying to play an electric guitar. Well, I did that by having two toroids, each one counter-wound to each other. So one was clockwise, the other counterclockwise. And I had a bit of an electric keeper because they were connected together in circular fashion. So I created a closed loop between them. And then the open circuit of my earthing appliance connected into that, went through it, and came back out the other side to the grounding rod outside. So I had a bit of an electric keeper there. But then I realized, well, I still need to disconnect from the grounding port on the electric outlet and use a separate line to a separate grounding rod outside. And I never corrected. I never changed, because I suspected having counterwound two toroids was neutralizing the influence I was getting from the earth. Not just neutralizing the AC hum bleed over. Well, now I didn't have an AC hum to bleed over to neutralize, so how come I didn't get off my lazy butt and rewind one of the toroids so that they both match? I didn't know whether or not it was important whether they be clockwise or counterclockwise. I just was too lazy to rewind one of them to make them to match, and that's what Clarence does in his circuitry. Both toroids, if you use a two-toroid system, are both clockwise wound, which means they're a match. So that was the change I refused to make, and Clarence has rectified. I can see the relevant importance, because we don't have to worry about AC bleed over, because we're running the system separate from the mains, from the power mains on our building. So now I have both toroids wound the same, and I'm looking at it, and I see that the way they're wound clockwise means that if you're looking at them facing up, laying on a table, and if we say that the south pole of the Earth means that the electron flow is from the geomagnetic North Pole towards the South Pole, then we're looking through. We're above the North Pole of the Earth, looking through what is the equator. The toroid represents the equator, and we're above the South Pole of the Earth. And we're looking towards the South Pole of the Earth, and the toroid is the equator. So when we look in the electric keeper, the center of the electric keeper, would be another like globe, rotating Earth, with its north pole facing up towards us. And this is entirely how gears mesh. If you have 3 gears, they have to counter-rotate with respect to each other in order to mesh without, shearing the teeth of your gears off. And so we literally have 3 gears. The 2 toroids are 2 gears, and the electric keeper is a gear between them. Now the Captor loop is also counterclockwise wound, as well as the electric keeper counterclockwise wound on the 2 toroids. And so that means that we have a 4th gear out here running to our earth ground. Not just the electric keeper is a gear in between 2 other gears represented by the 2 toroids. So we got 4 gears all together, and they're all meshing. And so the gear going to the earth is the same as these here. It's oriented the same. South pole facing up towards us. So it's a very interesting system, the way it's wired, the way it's the coils are wound. So let's see. The other changes I made was that I put diodes. I realized by experimenting recently, I started with a diode just on the bottom facing the earth ground. I had a wire coming out to earth ground. And I had my earthing bed sheet on the top, and I had just 1 toroid. And it was clockwise wound, just like this one. And I realized no diode up at the top, just 1 at the bottom. I had it facing, pointing down, and it was sucking the life force out of my body. Within a few minutes, I realized I had to change its direction. And I pointed it up, and it actually created a barrier. Because when I enhance my connection to the earth by using this system of 1 toroid wound with the grounding wire to the earth ground, an open circuit, I literally enhance the negative influences from my environment, my vulnerability to those negative influences while I'm on the earthing bed sheet. And when I put in the diode the wrong way, I leak out my life force from my body. But when I put it in facing in towards the electric field of the toroid, the magnetic field of the toroid, I literally created immunity to negative influences in my environment. And I would envision or theorize or hypothesize that those negative influences are coming from the AC field surrounding us in the wiring in our building that surrounds us. Because I'm very electrosensitive and I don't like AC. When the power goes out, I love it. It's very peaceful and natural and going back to nature because our AC fields are very disruptive to the voltage gradient of the entire physiology, the topography of the voltage gradient throughout the physiology. So I'm realizing that as I lay on the bed sheet, I took this from a quote somewhere on energetic forums. Somebody said that if you separate, it's a 2-step process to harvest Tesla's radiant energy. The first step is to separate radiant energy from the source, and the second step is to pass it through a magnetic field to process it or condition it to make it usable as, normal power, electrical power. And the separation is easy with a diode because if this is a DC circuit, because I also hypothesize that radiant energy is always in every electric circuit but going in the opposite direction, so that what diodes do, they point in the direction of the traditional so-called current that was theorized back in the 1800s, which turns out to be the opposite of electron flow. And so thus the diode is literally pointing the way, acting as a guide, a pointer, pointing the way in which the radiant component of electricity is flowing. And I imagine radiant power to be prana, and Maharishi defined prana as the space between the air molecules. So when you go up to higher altitudes, there's greater prana because there's greater space between the air molecules. Well, I envisioned that the radiant component of electricity, it can be defined in a way analogous to an NPN transistor or a PNP transistor, in which the holes, the electron holes, is what the radiant energy represents. And the electron flow going in the opposite direction are those holes filled with electrons. So when Edward Leedskalnin said there's little tiny north monopole magnets flowing in one direction of a circuit, and little tiny south monopole magnets flowing in the opposite direction, and that was his theory of electricity. This is kind of similar, in which one of those two mini monopoles, magnetic monopoles, is electrons, and the other is radiant energy, or prana. Basically a vacuole. Analogous to the vacuum state, people say, the zero-point energy, vacuum state, energy from the vacuum. Analogous to that, in that it's a hole, and that's where the prana is in the space, in the emptiness of an electric flow, though. So it's not necessarily in space per se. I mean, that's just ambient background, which is not flowing. We don't have a circuit there, but it's there. Okay, good enough. But in a circuit, it's there also, and it's flowing as well, and it's no longer ambient. It's actually active, and it's going in the opposite direction to electron flow. So I put the diode in there to separate the radiant component of electron flow from the electron flow component, because the way the resistance of the diode is set up, it'll be easier for the electrons to leave the toroid than it is for them to enter. And that means the radiant energy is going to be doing the opposite. It's going to be easier for the radiant energy to collect inside the windings of the toroid and stay there, and more difficult for them to leave because of the differential of resistance set up in the way the diode is constructed. So I'm able then to harvest a small amount of radiant energy and collect it within a magnetic field, the winding of the toroid. And so that's why I put the diodes here. Now, I've theorized the top diode based on my experience of the bottom one, because I don't know the top one. I haven't been able to, using my body like a dowser's body to sense what's happening. I don't know. I can't sense that, but this being the second diode that I added to the two-diode system. But the bottom one, being the first one, I noticed it very much. And it may just be that it was the first one, and so the contrast was the greatest, while the contrast of adding the second one is not so great. So maybe we only need one diode here, But it can't hurt, I would imagine, I'm speculating, to add the second one to pair them off so that they both complement each other in a balanced fashion, and create two gates at either end, encouraging radiant energy to collect at both ends of the windings, not just at one end. Okay, what else? Now I've also put in capacitors, because what I'm trying to do is enhance the system in a double-point way. One way, of course, is to use the mass of the toroids as my source of geomagnetism, so to speak, my substitute for geomagnetism. But the other way to enhance the circuit is to envision that what we have here is almost one module of an analog computer in LMD mode, namely longitudinal magnetodielectric mode of Eric Dollard. One of the very few transmission setups that Eric has shared with us, because he wrote in a letter to me that he has many, many variations on analog computers to study transmission lines. And then he shared another one. He came out with another version that I think he showed me in his letter, maybe not, or it might have been in one of his writings I found online, and then he shared it in one of his lectures recently. I think it was the 2015 conference lecture, in which he has his videos up on YouTube from the 1980s, from Borderlands video, in which he describes, Thomas Brown I think described initially in the beginning of the video the circuitry that they were using, and it involved two capacitors per module, this being the transmission line here, two capacitors in the middle, and then two coils on either side. Eric called them choke coils, radio choke coils. And they have to be balanced. The henries of the of the coils have to be balanced to the farads of the capacitors, because I suspect when I did it, when I created a biocircuit, the Henrys was too little and the capacitance was too great. The farads was too great. So effectively, I wasn't using any coils. I was just using capacitors, but I interleaved them. And this I learned on the Naudin website, naudin.fr in France. Somebody had posted, another fellow, not Naudin, but Naudin was hosting the page, that was regarding the interleaving of capacitors. And I adapted that, what I learned from that page, to my situation, was to interleave them so that this capacitor was positioned, let's say, over here, and this capacitor was positioned over to the right, and I had a floating plate in between the two pairs. You know, the leftmost plate of both are on the left, and the rightmost are on the right, and a floating plate in the middle making 5 plates. Because I realized for the polarity to be set up right, I needed a floating plate in the middle. Well, wouldn't you know it, if I interleave these capacitors, I can connect the floating plate to the aluminum foil shell surrounding both toroids, and I can tie the two foil shells together with a shunt, and I can tie the two toroids together with a shunt, and thus have my captor loop, instead of going to 56 grounding rods, I have it go directly connected to the toroids themselves. And then, of course, the other side of the captor loop comes down and goes over to the bottom end of my load, and the top end of the load is shunted to the electric keeper, and then goes over to the top end of the battery or DC motor source. Let's see what else was going on here. Now, the only thing I have to speculate, and I have to admit that it's speculation on my part, is where does the fuse and the neon bulb go? And my guess is that it goes to the Captor ground of the 56 grounding wires, and it's coming from the top wire of the load to complete the circuit, because the bottom end of the load goes through the Captor loop and comes out and goes to the Captor grounding rods, the 56 grounding rods. So that means if I'm going to the toroid with the Captor loop, then the fuse has to come from the toroid and go to the top of the wire, the top of the load, the top wire that's shunting down to the electric keeper. Let's see what else. And so the bottom wire of that's powering the bottom end of at least the left toroid, because this one it's flipped over. I keep forgetting to put it in. You'd always have to flip these connections over to match everything up right. But the bottom connection of the leftmost toroid, the shell of the aluminum foil is connected to the bottom end of the DC motor, so that the bottom the bottom end of the DC motor, which turns out to be the bottom end of the DC motor over here, because it's flipped over to this side of the toroid. So the bottom side of the DC motor is connected to the aluminum foil shell, and the captor loop that would have gone to earth, the 56 grounding rods, instead goes to the toroids. And that's where the circuit is picked up again. So now I've got the toroids energized. They're hot. They're hot with the load. They're going to be very hot. And, hey, it's my speculation. I'm free to speculate, right? Okay, so what else? Oh, yes, one other thing. How do I figure out the capacitance of these capacitors versus the coil winding on the toroid? And what I took a guess estimate was that since I'll be winding back and forth, layering layers on top of each other, winding my own primaries here on the toroids, I have to assume an arrangement of, if I can get my little diagram, my wire winding diagram, 7 wires in a hexagonal arrangement, 1 in the center and 6 surrounding, on these toroids. in which there's 6 surfaces of the outer wires matching up with the wire on the inside. So the inner wire has 6 surfaces connecting 6 wires together. That means the length of the wire, if I divide by 6, will give me a value, which if I square, will give me the value of the square area of one plate on the capacitor. So I have to take the square root of the area of the area of the capacitor plates used on the capacitor and make that equal to 1/6 of the length of the wire that I use to wind the toroid with. So if Clarence says 2.5 windings of the electric keeper and 242 turns of wire on the toroid, divide the 240 by 6, I get 40 turns. No, excuse me. I have to take the wire off or pre-measure it, pre-mark it before I wind the toroid to figure out how much length of wire I used. And then take that length, divide by 6, square it, and that'll give me the square area of each of the plates of the capacitor. Now, the capacitor I'll probably make my own, of course, in a manner that I learned from John Bedini, or was it Peter? No, John Bedini, when he did his episode 38, I believe, disc number 38, A and B, part 1 and 2 of Energy from the Vacuum series. From the Chenier.org website, associated with Thomas Bearden, in which John Bedini talks about the Lockridge device that Mr. Lockridge, Private Lockridge from the U.S. Army, had picked up from somebody's home when they were invading Germany at the end of the war. And what the guy did was he used an alternator out of an old Volkswagen. I believe it was a Volkswagen motor, but he used an alternator and he created his own capacitor made out of butcher paper and copper sheet, rolled up into a roll to conserve space, I guess. But basically, yeah, because it was a long ribbon of copper sheet and butcher paper rolled up. And so I'm probably going to have to do the same to create my interleaved capacitors. I'm probably going to have to use some kind of sheeting. I don't know if it has to be copper necessarily. Maybe I can get away with using aluminum foil. And interspersed with craft paper I'm going to use, because craft paper comes with glue on one side. I also have rosin paper I could use if I want to use that. So I have paper of different widths and whatnot. So I'm going to roll my own capacitor. I'm going to make it interleaved. So my 2 capacitors on top and bottom are going to be interleaved to keep the polarity, to get them to phase lock. This is the point of interleaving them, is to make sure the top and the bottom are in total phase lock, because maybe they come out of phase slightly. Maybe there's an imbalance between the top and bottom of the circuit by some means or another, and I want to make sure they're in phase lock to make sure that I don't create beat frequencies that could undermine, create a parasitic transient within the circuitry that will suck away the energy from the entire circuitry and undermine its inherent resonance. I want to make sure that doesn't happen. So I'm putting in the capacitors to ensure that that doesn't happen. Now I'm blocking the flow of energy that normally would go between these 2 toroids, so that now they're not flowing anymore. They're ricocheting off, coming off this side going this direction and coming off the other side going the other. So I'm creating 2 halves, in a sense, of an alternating circuit. One side is going one way and the other side is going the other way, but because it's locked in with a DC power source, it doesn't flip, it doesn't alternate like an AC circuit would do. So if I changed my source to AC, then it would flip back and forth. Now because of the I shouldn't have any problem with the sine values on either side of the capacitor. Everything should work out, provided my coil matches my capacitor, maybe, I don't know. Or it may still not matter. So I don't know, it may be okay. I'm hoping, I'm guessing. So the floating plate that is shared between the 2 interleaved capacitors will go to the aluminum foil. And so will the bottom leg coming out of here of the DC motor. Which still makes this connection going to the aluminum foil an open circuit, which means my floating plate is not compromised, is not part of a circuit. It's still floater. It's still a floater, but it's an open circuit floater. It's not a detached floater, a total floater. It's not an absolute floater. It's a partial floater because it's an open circuit connected to the bottom end of the DC motor or bottom end of the battery pack momentarily, for that matter. So those are all the changes and modifications I'm making. The toroids are still wound clockwise, and the electric keeper is wound counterclockwise around the toroids, and the Captor loop is counterclockwise around the electric keeper. The fuse is, you can only get readily available fuses that are geared for 100 volt AC circuits. So I'm going to be blocking myself with this neon bulb if the voltage does not rise above a certain minimum, somewhere between 70 and 90 volts. I'll say it's like 84 volts. I'm not sure. I can't remember. Somebody did a video in finding out what the voltage minimum is of these neon bulbs, and it was somewhere, I believe, around 80 volts. I'll say 80 volts plus or minus. So if I don't get the voltage up high enough, this circuit may not work, because the neon bulb will act as a break in the circuit. Now, it won't be a complete break because we've got a neon gas inside, and it's going to create ion tunneling between the two filaments within the neon bulb. So in a sense, the neon bulb is acting as its own resistor if the voltage is below its operating voltage minimum. So I've got two resistors here, and then I got a 100 kilo ohm resistor over to the side here, on the side facing what would have been the earth. In this case, it's the metallic substance of the iron toroid itself. So I got two resistors, one which doesn't have a threshold, it just operates at any voltage, and the other one has a minimum operating voltage parameter, which is kind of interesting. I don't know what to make of that. So the full power of the system will not operate unless it goes to a minimum of what the neon bulb is geared for, somewhere around 80-90 volts. Which is kind of interesting, because that means that might be why Clarence had said in one of his posts that he couldn't get the system to run at a very low scale power to simply be proof of concept. He could either just do it or not do it, and he couldn't go anywhere in between, and I think it's the neon bulb that gets in the way. I can't imagine what else could be getting in the way. I mean, we don't have an AC inverter here to get in the way. We can make the DC, well, although the DC motor in this case, they don't come any lower than a couple of volts, like 2 or 5 volts if you get one off the shelf, which means your battery pack has to match. It has to be like, what, a 3-volt battery pack or something, minimum. But that's way less than what the neon bulb's minimum is, and the neon bulb wasn't even rated for DC. It was rated for AC, 80 or so volt minimum. So I'm dealing with some questionable areas in here, obviously. And even the capacitors are questionable. The diodes are questionable. All kinds of questionables. And normally you're not supposed to change more than one questionable at a time, right? If you're trying to be scientific, doing a perform a controlled experiment, you're only supposed to change one variable at a time. And in the beginning, you're not supposed to change anything. You just replicate Clarence before you make any changes. But I studied the thing till everybody else on his message threads were blue in the face to try to figure out and understand what's going on so that I can make changes ahead of time. Based on my prior experience. I was trying to match up my prior experience because I feel there's enough similarity to overlap my prior experience with my earthing enhancement device versus this Barbosa and Leal, versus this Clarence's replication of Barbosa and Leal device. There's enough overlap, enough similarity, so I was trying to understand them in terms of each other. And I don't know, I think I've done a successful job, at least in theory. So now I get to find out. And the problems are multiple that could get in the way, some of which have nothing to do with my theorizing, just the fact that, well, no, it does have to do with my theorizing because I've taken away the AC inverter. So my neon bulb might pose a hazard in which full power doesn't arise. So I'm just going to try out, what would happen without a load over here, just idling the system. Because that's might be all I get to do if I can't get the voltage up high enough to illuminate the neon bulb, is that this will be idling in a very micro way. So micro, so nano, that the DC motor, I won't even be able to find a DC motor online to be able to turn. And if I make my own, I'm not even sure that I can disallow friction sufficiently for it to rotate. Now, if I get one of those radiometers, I think they're called, they're a glass bulb with evacuated glass on the inside, and they have two foil pieces, diamond-shaped pieces, that rotate around and spin. And I think it's to show you that they're in the radiometer is in a electrostatic field, because the two sides of the plates are differently charged, and it causes them to spin in a specific direction. That might work if I knew how to connect it up and replace the DC motor with that radiometer. That might work. And then I could take out this battery pack and just use the mild voltage between earth ground and an elevated aerial, the difference between the two. The voltage difference wouldn't be a whole lot. They measure voltage difference between earth ground reference near a tree and the sap inside the tree. And there's a slight voltage difference. That's why it's usually, for earthing purposes, it's usually better to sleep at night grounded to the earth, because it's more settling. The tree has an elevated voltage with respect to the earth, and that might not be as restful, but you get the intelligence, consciousness of the tree as a factor in your circuit if you're using a bionic circuit connected to the body during sleep at night. But for the purposes of this, if I try to use the earth as my only source of energy to kickstart this into being, then I may have to take out, obviously the battery pack is taken out at this point and is serviced by a grounded aerial. Actually a non-grounded aerial on one side and an earth ground on the other. And the DC motor has to be taken out and replaced with something sensitive enough to both rotate and be electrically connected into the circuit to create a rotating electric field. Because if we rotate the electric field, the magnetic should catch up. And the radiometer might be the thing to put in. I'll have to look online for radiometers to see how they're wired, to see if two leads come out of it that I could use in place of the two leads coming out of a DC motor. I don't know. I'm not about to try to figure out how to make my own radiometer. And then the neon bulb will definitely be a hazard. So I might just want to put another radiometer right here, which means I don't even need this one here. Ho, that is interesting. Indeed. No, actually, no, I will need two, because this only operates if I have this connected. If I have this load disconnected, this neon bulb now becomes disconnected, and so now I need two radiometers, one here to replace the neon bulb and one here to replace the DC motor. That's what I need. So it was good I made this video. I got to think through something that I wouldn't have been able to think through otherwise, because I was clueless. What do I do to replace the DC motor? And in the course of figuring that out, I figured out how to replace the neon bulb. Woohoo! So, maybe, in theory. I'll have to look it up online and see if that's possible. Anyway, so far, this is what the circuit looks like. Obviously, it's not complete because we have two problems, the DC motor and the neon bulb. Because I'm not going to be able to construct a system that's powerful enough to have a high enough voltage for the neon bulb to light up on one side. Normally, a neon bulb in an AC circuit, both filaments light up, or give the appearance of lighting up, because they're actually alternating, but they don't dim. Each filament doesn't get a chance to dim. It's kind of like a flywheel, so kind of like having the flywheel on the DC motor. Each filament does not die off fast enough, and so it looks like they're both on, when in reality they're alternating. They just don't fade fast enough to show you that alternation. But if the alternation slowed down enough, you'd be able to see it. So usually in a DC configuration, only one filament will light up and the other one will be vacant. So they can be used in a DC circuit if the voltage is high enough. So I'm going to have to take out the neon bulb and put in something else, and maybe a radiometer, if I'm saying it correctly, getting the name straight, is what I should replace the neon bulb with, and also replace the DC motor. Well, I found out that the radiometer that I was referring to, that I wanted to put in here in place of the DC motor and the neon bulb, does not have two leads coming out of it. So I won't be able to use it as a sensitive means of rotating an electric field in a circuit. Possibly the coils do it themselves, but I wanted something kinetic to introduce motion. Possibly, I don't know, I'm just hypothesizing that the motion of a coil, the rotation of a coil, will add a kinetic element to rotating an electric field if that coil is involved in interacting with, let's say, permanent magnets in a DC motor situation. So I don't have a substitute for the DC motor, but in the meantime I'm still working on building up my circuit from scratch, one element at a time, starting with the enhancement of the earthing experience. Now I want to add on a second coil, which means now I get to add on capacitors. And I realized that the floating plate of the capacitors are linked to the foil. That's what I have. So it was a good thing, that's what I have in this schematic. So it was a good thing I did this in advance of knowing all the answers about how I'm going to do it. Because at least I worked out some things. That the neutral of plug number 2 of the AC sine wave inverter should go to the foil, encasing the sand or paper, preferably sand, quartz sand, surrounding the toroids. And that means I don't get to set up the other grounding lead that goes directly to the toroids yet, because I don't have a load. I'm not working with a load. I just want to idle the system. Plus I want to get familiar with it before I add in a power source, such as a battery, or a DC motor for that matter, powered by a battery. So I still, though, get to hook up one of the two sets of grounding rods, the set of 4 grounding rods that are in the center of the 56. And that goes to the floating plate of the interleaved capacitors on the one hand, and it also goes to the foil covering the sand that surrounds the two toroids. And I'll be connecting one side, this bottom side of this toroid, to earth ground, which does not happen here. It goes to the bottom end of the battery pack here, or DC motor for that matter. But here it goes to the earth, and then the other side, instead of going to the other side of the battery pack, goes to my earthing bed sheets. So it's a slight adaptation of what eventually will become a machine to power other machines, and I won't be involved. But this is just to test out development of the circuit, you know, the placement of the diodes and yada yada yada. So now at least I know what to do with this floating plate, and that's good. So this is what I'm going to do. This is what I can do now, and so I'm going to do now, is add this second toroid, unwrap this electric keeper, because right now my electric keeper is all wrapped around 5.5 times around my single toroid. And of course I'm going to take off the neon bulb and the little aluminum foil hat. And I'm going to this is my second toroid here, and I'm going to add in 2 diodes. Now, there's one other thing I should do, and that is rewind both toroids, because I have this going all the way around, and I should only be going halfway around, such as I have it in the diagram. So why shouldn't I conform to the diagram? So that means I'm going to have to rewind these toroids very firstly, instead of going all the way around, just halfway. I'll be doubling back on top, so I'll make a second layer. Of course, it's not magnetic, enameled magnetic wire. I could have done that, but in this first setup, I'll just use the 18 gauge aluminum core, copper clad, solid core, not multi-stranded audio wire that I got, and because it's already there, so I'll just have to take off half and rewind the other half. Maybe next time I'll use the magnetic wire, the enameled magnetic wire. Oh, and I'm also going to do this. I'm to help strengthen the foil, I'm going to put a layer of saran wrap underneath the foil on top of the sand. I already have plastic insulation on the toroids in the form of electric tape and surrounding the wire that I wind around the toroid. So I thought, well, what could it harm to put saran wrap on the underside of the foil as well? I'll have plastic on both sides of the sand. And that way I'll make sure the foil doesn't rip and spill sand all over the place. What else? I think that's it. I've already covered the interleaving of the capacitors. I can't free my hand, but basically one capacitor on one side goes, let's say, to the left, and the other one will go to the right, or it could go the other way. And then the floating plate is down the middle of the two plates on either side. But it won't be floating plate anymore. It'll simply be connected to the foil, which is another floating plate. So both foils, we're going to have them shunted together. So we're going to have 3 floating plates connected together, basically, but connected to the bottom end of the circuit. This is important. So the floating plates now are similar to the earthing bed, except they don't go through the toroid winding. They bypass that. They go directly to earth ground without any modification. So it's another open path line, which kind of makes them like an aerial of a sort, except I'm not making them an aerial. I'm making them a floating plate in these 2 interleaved capacitors and a floating plate surrounding a shell, acting as a shell or chassis surrounding these toroids. And instead of blowing air through, compressed air, to kill a arcing, I simply have quartz sand instead, which is serving as a substitute for dry soil that would be outside. But the geomagnetism is being supplied not by the earth. I'm just grounding this because I want to sleep on it. It's being supplied by the toroids, but inductively at the moment through the coils, not directly, because I have no captor loop to connect to the toroids directly. So those are the kind of modifications to this simple setup to the more complicated target. You know, this is still subject to modification as I go along, but I got to start somewhere. And I'm in an intermediate step now of expanding, going from 1 toroid to 2, with an electric keeper in between, and 2 capacitors, and foil, and sand. So I got several additions to add here, and 2 more diodes over here, just like I have 2 diodes over here. So it's an expansion of several types, foils and sand surrounding this one as well. But this is not grounded. None of this is. This is only grounded on one side. I don't see why I would want more than one grounding, because the power source is here. And so the substitute for the power source is me on top and the earth on the bottom. Otherwise I would take these out and put in a battery over here, and possibly the DC motor, which is conjecture at this point. Thinking this over, I realized there's not a whole lot of magnetic field charging up the toroids, even just in idle mode, without a power circuit, without a load circuit, I mean. Just this power, the source circuit. Of course, there's no battery here, but all the same, you know, and even without any concern for a captor loop attached to earth ground, you know, 56 grounding rods. So I began to think, well, because I have to look at the situation simply from the ground up, from the kernel, actually, from the center up outwards. And of course it starts on the left hand side with 1 toroid, you add another, and then before we even get into a power circuit, I mean a load circuit to be added on, which would include the captor loop. But without that, there's no consideration for earth ground power, and yet, despite that, it is inductively, if I'm planning on using these toroids for the source of my geomagnetism, so to speak, I'm going to need to attach a little magnet, maybe not so little, 1 to each toroid, since I have them physically separated. I don't bring them together. In my old system, in earthinglife.info, I sandwiched these 2 together. But we've got an electric keeper in the middle, so, you know, traditionally Clarence keeps them separately, so I'll put a magnet on each, a neo bar magnet, positioned, I guess, on the back side, on the underside. It's fairly long. It's several inches long, and it's about 1 inch wide. It's not a flat one, it's a squarish proportion. And that'll impart magnetism to each toroid, regardless of whatever comes from the Earth, voltage difference between me and the Earth in this setup, or even here if I end up putting a battery in, regardless of an external power source. And I think I have to do that. I didn't draw it here, but I'm not doing this yet. I'm doing this more simpler, and I'm simply going to have to put I have ferrite circular magnets, but these toroids are quite wide in the middle. I mean, I could put it in the middle if it fits, but I would just assume turn it over and on the flat side put a bar magnet maybe across the middle here, since the wires are going to be all on one side, these purple wires, which should be magnetic wires, right? And then the electric keeper wire is going to be on the opposite side, and then in the middle I could have going across the bar magnet, or else I could have it maybe over here on this side. I know I'm going to have to do something, maybe up here, I don't know. Whatever, I'm going to have to do something because there's just not enough magnetic force that's going to be contributing to these toroids. I'm going to go to the toroids for magnetism indirectly by connecting to the aluminum foil shell at this stage of development, but I still have to prepare or get ready using whatever means I can, short of adding the Captor loop and the power or the load circuit, which is removed from this. And that means adding a magnet to each toroid. So that's what I'm going to do, in addition to everything else here.